Hello guys, welcome back. This is type 5 and in this type we are concerned about pulley problems. And there are many cases in pulley problems, and the first case A, is the case in which the pulleys are at rest. And there are some assumptions which we will assume during these problems, that pulleys are frictionless and they do not apply any friction force on the rope which is passing through them. I mean to say, when this rope is passing through this pulley, there is no friction which this rope is applying on the pulley, or there is no friction which pulley is applying on the rope. It is a very important conclusion, as we can see that if there is no friction along the pulley, then the rope will slide on the pulley and it will not rotate the pulley. But in general practice, when we imagine a pulley in pulling a bucket of water from the well, then that pulley rotates due to the fact that rope and pulley applies friction on each other. But if there is absence of any friction along the pulley, then the rope will slide from the pulley. It will not rotate the pulley. This is a very important conclusion, because if pulley will be rotating, then this problem will be a problem of rotational mechanics. And the second important point is the fact that until and unless it is given that pulley has some mass, we will assume the pulley to be massless. Okay, these two assumptions are very important in pulley problems. So the basic pulley problem is shown in the figure, in which this pulley is at rest. Obviously we are dealing in case A, in which pulleys are at rest. So you have to firstly determine that pulleys are at rest or not, and you can determine this fact by watching carefully that that the center of pulley is attached by a rope or a rod by some fixed surface. If this rope is attached from the center at one end and its other end is attached to a fixed surface, then this pulley will not move. So in these problems, we can say that there will be no friction that pulley will apply. The pulley is massless and pulley is at rest. Now there are two masses. You can see that this is 3 kg and this is 2 kg, and due to the fact that the pulley is not moving, therefore we can say that if 3 kg will go down, obviously 3 will go down as its mass is greater with some acceleration A, then 2 will go up with a same acceleration A. So their accelerations will be same, and this is due to the fact that the pulley which is between these two blocks is at rest. So when a pulley is at rest, the blocks which are on both sides of that pulley have same magnitude of acceleration. Okay, now as there is no friction in the pulley, therefore we can say that the tension in this single rope, obviously it is a single rope, will be same. Okay, and this tension will also be pulling the pulley downwards. Now if I imagine the free body diagram of 3 kg, then there is a force mg which is 30, and there is a force mg which is 20 acting on these two blocks. And I am writing the equation of 3 kg block. It will be 30 minus t, and it will be equal to 3a. And I am writing the equation of 2 kg block. It will be t minus 20, it will be equal to 2a. Now 30 minus t is due to the fact that 30 is greater than t, as the block is 3 kg block is moving towards 30 Newton force, and t minus 20 is also due to the fact that t is greater than 20 for 2 kg block, as it is moving towards t. So if I add up these two equations, then it would be 10 will be equal to 5a, and a will be equal to 2 meters per second square. And if I substitute the value of a, then the tension will be equal to 20 plus 4, which is 24 newtons. Okay, now I am demonstrating you a simple way to do these kind of questions in which pulleys are at rest. So you can see that this system, this block has a mass 3 kg and this has a mass 2 kg. So the trick is the fact that they are moving in opposite directions, and obviously the mg of this 3 kg block is pulling it towards pulling it down, and if 3 kg block will move down, then 2 kg will move up. But if 2 kg is moving up, then its mg, the mg of 2 kg is trying to pull it down. So we can say that 2 kg is being pulled by the mg of 3 kg in upward direction, and 2 kg is being pulled by its own mg in downward direction. So we can calculate out the net mg. So net mg, I'm writing this trick here. Net mg will be 30 minus 20. This will be 10 newtons, and obviously they will be moving together always, because rope is taunted. So we have to equate this 10 newton to 3 plus 2, 5a, and a will be equal to 2 meters per second square. So what I have done, that I know that the mg of these two blocks is pulling these blocks in opposite sides. So I have to subtract the mg of the blocks, and I have to add up the masses, and I have to multiply it with the common acceleration. So I can say that if there is a mass, there is a pulley which is connected with a fixed surface, there is a mass m1 on the right side and the mass m2 on the left side, and m1 is greater than m2, it is given to us. So I can say that m1 will move downwards and m2 will move upward, and if I have to write the acceleration directly, then it would be m1 minus m2 g, and divided by m1 plus m2. Okay, so this is the direct trick or formula to calculate the acceleration in these kind of questions. Now we move on next question. Now in this question we can see that there are 3 blocks which are connected with a pulley, and the majority of the mass is towards left side of the pulley, and the minority mass is towards right side. So I can say that this system will go down with some acceleration a, and this block C will move up with same acceleration a, due to the fact that the pulley between these blocks is at rest. So their accelerations will be same. Now there are 2 different ropes. This one is first is this rope and other is this rope. So there will be 2 different tensions in the ropes. So to calculate the acceleration a, either we can use the conventional method to write the equations of free body diagram for all 3 blocks, or either we can use our trick. So if we go by our trick, then we can see that a will be equal to the combined mg of this system is 4 kg. So 4 minus 3 g upon the total mass of the system, which is 7 kg. So A will be equal to G by 7. Okay, so block 1 kg will be moving with acceleration G by 7 downwards. So correct option will be option number C. But we have to also find out the tension between A and B. So if we have to find out the tension, we can assume it as T, and we can write the equation of this 1 kg block. This 1 kg block is moving downward, and its mg, which is 10 Newton, is acting downwards. So I'm writing it as G, 1G. Okay, now minus T is equal to 1A. So A is already G by 7. So T is equal to G minus G upon 7. So it will be equal to 6G upon 7. This is the tension in the rope which is connecting 1 kg block. Okay, now we move on. Next question. Now in this problem, you can see that both the pulleys are at rest, and I'll demonstrate this problem with both the approaches. First is conventional and second is the short trick. So firstly, by conventional method, I can write out the tensions. So this is T1 and this is T1, as this is a same single rope, and this is T2 and this is T2 also. Now I can see that 12m is greater, so it would be moving with acceleration A. 2m will be moving towards right side with the same acceleration, and m will be moving upwards with the same acceleration. Now writing the equation of 12m, I can see that 12 mg will be acting downwards, and if 12m is moving downwards, then 12 mg will be greater than T1. So greater force 12 mg minus smaller force T1 is equal to 12 MA. This is equation number 1. Now for 2m, I can see there is no role of mg in 2m because its normal reaction will be balanced by 2mg, or I can say that 2mg will be balanced by normal reaction, but its motion is going in x-axis, so I have to write out the equation of x-axis only. So in x-axis, 2m is moving towards right side, and the greater force will be T1. So greater force minus smaller force will be equal to 2ma. Second equation. It is very important to note that there is no involvement of its mg in this motion, in this equation. Now mg, this m mass is moving upward with an acceleration a, and its mg is moving downwards. Its mg is acting downwards, and obviously if it is moving upward, then its tension T2 will be greater than mg. So its equation will be T2 minus mg will be equal to ma. This is the third equation. If we add up all these three equations, first, second and third, we can see that it is 12 mg minus mg will be equal to 15 ma. So A will be equal to 11g by 15. Okay, this is the required value of acceleration, and if I substitute this acceleration in these three equations, I will be getting the value of T2. But if I am demonstrating this by the short trick, then I can say that the pulling mgs, firstly I have to calculate the mg of all the blocks which are pulling this system. So 12 mg is pulling this system downwards towards right, and this mg is pulling this system downwards towards left, but it will move towards 12 mg. So I can say that acceleration will be equal to 12 mg minus mg, and upon these all three blocks are moving. So if all three blocks are moving, then we have to take the complete mass of the system. So it would be m plus 2m plus 12m. So it would be 15m. So A will be 11g by 15. Now you should have noted that we have not taken the mg of 2m in the numerator because its mg 2mg is balanced by normal reaction. So 2mg is not playing any role in the motion. So this is the required acceleration. Okay, now we'll move on the next type. Thank you.